Okay, 14.2, day number 1. We're going to construct sinusoids. What? What is a sinusoid? Well, ironically, a sinusoid is a sine function or a cosine function. So sinusoids is this family of sines and cosines, which yesterday when we looked at that one problem, you can write any given problem in an infinite number of ways. Right, in an infinite number of sine functions or cosine functions based on some vertical reflection. Now I forgot what I was doing, but basically you could take any sinusoidal function and fit it with a sine function of infinite, I don't know what the right word for that is, but you can fit an infinite number of sine functions because I could just, what could I always do? Just shift it. Shift it the length of half of the period, right? Because, oh no, the full period. So shift it a period length forever. So could I say this, and this is something we're going to see later on this semester, sine of t, right? Would this coincide? Yeah, just lock right back up, right? I'd shift it 2 pi. Okay, so could I do that if it were minus? Yeah, I could do that if it were minus. Could I do it if I added any number of 2 pi's? Yeah. So k could be 1 or 2 or 3 or 4 or 5 or 6 or a million or, you know, whatever my paycheck is. Notice I went increment. Okay. Okay, so there's an infinite number of sine functions that would look exactly the same. Right? Okay. Same thing with cosines. We're not going to go there. But you are going to see this 2 pi k thing show up again later. Okay. Tide Lab, I don't know that we're going to get to this before break. So if we do it, it'll be after break. It has to do with tidal waves and all sorts of fun stuff. Okay, so here's my patriotic Ferris wheel. Dwayne, our custodian, he likes Ferris wheels. I don't really know. I just, the first name that came to mind, because as I was writing this, I heard him go by on his little Zamboni, hallway Zamboni, so it was in. So Dwayne rides a Ferris wheel, boarding at the bottom, 10 feet off the ground. If the radius of the wheel is 35 feet, it takes 5 minutes to complete 1 revolution. Write 2 sinusoids, one using sine and one using cosine for this model. Okay, so let's just do a little graphic here. Let's say that our x-axis is not an x-axis, it's a t-axis. And our y-axis is height. Height above the ground, okay? So at time 0, how high off the ground would you be? 10 feet, okay, 10. Okay, at time 5 minutes, right, this is in minutes. At time 5, what would your height be? 10 feet. I'm back to that spot where I'm going to get off of the ride and, you know, hopefully go get some protein powder cotton candy with Dwayne. Okay, so at halfway through, at 5/2 minutes, I know it's kind of weird, but 2.5 minutes, what is my height? Well, let's think about that. What's the radius of this? 35. So I double it. Looks like we're 80 feet off the ground. Plus the 10, right? Okay, I'd like you with a neighbor to write a cosine function and a sine function for that graph. Do your best. We'll take about 5 minutes. Fill in the information, and then we'll come back and revisit and see how well you did. Go. Okay, Zach wants to share. Okay, Zach, what did you get for A? 35. Okay, good. Built into this, you guys, A is typically going to be the radius. Actually, it's always going to be the radius of whatever it is you're working with. Right, so if I give you the diameter, divide by 2. Okay, so I use this formula to find A. I took the max value minus the min value. Notice minus because if you have an A in the class, where's the only place your grade can go? Down, up. The heck? What do you think? 105s exist in this world? Okay. I know. Too soon, too soon. Okay, B is determined by taking 2 pi and dividing by whatever the period is. So in this case, B is going to be 2 pi divided by 5. Okay, now let's ask for some other stuff here. Okay, was it Zach you were helping me? C and D, give those to me. 5/2? Okay, so you decided to, okay, I can go with that. 5/2. And then what'd you get for D? 45? Okay, works. Did anybody change their value for C? Yeah, Grace, what'd you have? Good. So if you decide that you want to put a 0 in here, let me get a little crazy here. Creative pen. Let's go with the radioactive hot dog here. If you put a 0 in there, okay? If you put a 0 in there, then this must be negative. Okay, backtrack for a second. Let's look at Zach's graph. Zach's graph is going to start here, and it's going to go 1 full period there. He decided, I don't want to do the vertical reflection. That's fine. Children that decided they like radioactive hot dogs decided they were going to graph this portion. This is 1 full period as well. Good? Okay. So either of those two would be acceptable for the cosine. And if you really wanted to get, like, you just wanted to terrorize your teacher, you could shift it. What would that be? 30 pi or 30/2, right? Just add 5 to whatever. So I could add 5 as many times as I want. Uh-oh. I could add 5 to that as many times as I want. Good? But then you'll have to alternate between, negative, positive, depending on where you end up. Okay, let's get rid of that for a second. Did anybody get to the sine function? Yes? Maddie, what'd you get? That's okay. Okay.
Sine of 2 pi/5, and t plus 2.5 plus 45.
Okay, so one thing that you can do immediately is you can lock in a couple of these numbers. Which ones won't change? Actually, 3 of them. What won't change? A, B, and D. Those aren't going to change. You just lock those in. The only thing that's going to change is whether or not it's reflected and the shift. So let's highlight where Maddie's graph would be.
I said plus.
You said plus. Okay. All right. My bad. Let's see. Okay. So you're telling me I'm going to shift 5 pi/2 to the right. Okay. So that would start here and would go there. Is that a sine function if I were to squint at it? No, it's a cosine function. So Maddie, we just need to change your shift. What should we change her shift to? 5/4. How about that? Right, because wouldn't that be half of 5/2? That'd be 5/4. And a sine function starts at the baseline, goes upward. And so Maddie, that would work. Somebody else do a sine function differently? Okay, that would be optimizing, minimizing the amount of work you'd have to do. Someone might do this. I don't know. Yeah, they'd go, what'd you say, Eddie? Oh, over here? Yeah, so this is 15/4. So their shift would be 15/4, but then what? Yeah, then we'd have to have a negative out in front. It works. A little bit more work. You got to think about fractions. You got to manipulate and try not to screw it up. Okay. I believe that's it for notes for today. Isn't it nice to know you have an infinite number of possible answers? So you can't screw it up, right? A wise person, my father, calculus teacher for a long time, once told me that calculus is useful when it's useful. So that Statement makes sense when it makes sense.
What?
If you know what you're doing, then an infinite number of answers is great. But if you don't know what you're doing, then thanks for that. I'm basically running around with my eyes closed, trying to cut my hair, which I don't have any of. Yeah, thank you for. I'm a mature 48-year-old. Like, subscribe, comment below. 100th sub, $10 to GNC.